This video is on operations with numbers expressed in scientific notation. We're going to look at how to apply the rules for exponents in the process of performing operations on numbers written in scientific notation. Here you see the format a times 10 to the x, which is a format for scientific notation. It's a number written where a is a number that is greater than or equal to 1 and less than 9. Let's look at a couple of examples. 5,000 in scientific notation is 5 times 10 to the third. 34,000 is 3.4 times 10 to the fourth. And 234 million is 2.34 times 10 to the eighth. And how do we do that? This would be review. You have the decimal point located to the far right of the number in 5,000. Move it back 1, 2, 3. So 5 times 10 to the third for 34,000. 1, 2, 3, 4. 3.4 times 10 to the fourth. And similarly for 234 million. Okay, now that we've reviewed, let's look at a few problems. This one is addition. The first thing we do is we add the coefficients. 3.15 plus 5.34 gives us 8.49. As long as the exponents are the same, then the sum will be 8.49 times 10 to the fourth. Now here's an example where the exponents are not the same. 3.15 times 10 to the fifth plus 5.34 times 10 to the fourth. If the exponents are not the same, rewrite one of the numbers in the form of the other and then add as we did in the first example. So I took 5.34 and times 10 to the fourth and I wrote it in the same form as the other add-in, so I need it to 10 to the fifth. So what do? I move that decimal point back one space, 0.534, and I increase the exponent by 1. Now that they both have the same base and exponent for one of the factors, now I'm just going to add the numbers together, the coefficients together, just like I did the first time. 3.684 times 10 to the fifth. Let's look at a subtraction problem. You're going to see it's very similar to the addition. So what do? I subtract the coefficients as I normally would. I get 4.9. And as long as those exponents are the same in the other factor, I just bring that down times 10 to the third. Now if the exponents are not the same, as you see in the second example, we're going to do the same thing we did with the addition problem, and that is we're going to rewrite one of the numbers in the form of the other and then subtract as we did in the first example. So 7.3 times 10 to the fifth minus 2.4 times 10 to the fourth. I'm going to rewrite that second one in the same form as the first. I move the decimal point back 1 and I increase the exponent by 1. Now they both have the same base and exponent as one of the factors, so I subtract 7.3 minus 0.24 gives me 7.06, and it's going to be times 10 to the fifth. You'll find multiplication and division to be a lot easier. So here's a multiplication problem. I'm going to multiply the coefficients, 3.3 times 2.4, and then the rule for multiplying exponents is keep the base and add the exponents. So 7.92 is my product of the coefficients times 10 to the third plus 10 to, or times 10 to the third is 10 to the sixth. Now here's another one. 5.2 times 10 to the fifth times 3 times 10 to the fourth. Alright, what do? I'm going to use the distributive property and I'm going to multiply the coefficients. And then I am going to add those exponents, 5 and 4, and I get 10 to the ninth. That's fine. But that final product is not in proper scientific notation. So I do write it in proper scientific notation by moving that decimal point back 1 and increasing the exponent. 1.56 times 10 to the 10th is the product. Now let's look at a division problem. 2.7 times 10 to the 5th divided by 9 times 10 to the 4th. We're going to divide the coefficients. 2.7 divided by 9 is 0.3. And the rule for dividing exponents is keep the base and subtract the exponents. So if I do that, I keep the base 10 and I subtract the exponents 5 minus 4, and that gives me 1. Well, as you can see, that final quotient is not in proper scientific format. So what I did is I expanded it and got 0.3, and then I take 0.3 and I'm going to write that in proper scientific notation. Well, in order to do that, I have to move the decimal point one place to the right. I'm moving it to the right, not to the left, so that means it's going to be 3 times 10 to the exponent is going to be negative to the negative 1, because I'm going to have to move it backwards 1. Okay, let's review the rules for addition and subtraction. In addition, we add the coefficients. If the exponents are the same, we multiply the sum by the base and exponent. If the exponents are not the same, we rewrite one of the numbers in the form of the other and then perform the addition operation. Subtraction, subtract those coefficients. If the exponents are the same, multiply the difference by the base and its exponent. If the exponents are not the same, rewrite one of the numbers in the form of the other and then perform the subtraction operation. Let's review the rules for multiplication and division. For multiplication, you're going to multiply the coefficients, and you're going to then use the other factor is going to be use the base 10 and add the exponents. For division, you're going to divide the coefficients. Then the other factor will be times 10, where you then have subtracted the exponents. And one last note, and this is important. Your final solution, whether it be a sum, difference, product, or quotient, should be written in proper scientific form. Okay, that ends this video on doing operations on numbers written in scientific notation and applying the rules of exponents in the process. Enjoy the activity.